like everybody for being so like dedicated today and staying the whole day. Really, really appreciate that. So I hope you guys are learning a lot, and I hope this has been, really helpful for you guys to understand more about, how you guys can get involved. So we're gonna basically continue off with the challenges from where Tam went off. If you guys go to Speedrun Ethereum, at some point you guys need to get a wallet. So I already have MetaMask installed. So we can actually come in here, connect the wallet, use MetaMask, and then now we're signed in here. So challenge 0 is actually really easy. Like anybody can do it. It literally takes like 20 or 30 minutes. So I would give that as your guys's like goal today, is try to do this. Try to find like 20 or 30 minutes to sit down and figure this part out, because it doesn't really involve any coding at all. You guys can just walk through it. It's really easily. Obviously, the staking app you guys just saw is a little more complicated, and also goes for the token vendor. The token vendor is definitely a little bit of live coding, but at least you guys have an understanding of what you need to do. So we're going to focus on the token vendor today. So we can click that. Oh, and actually we want to connect to a different one. Let's connect to this one. How do I? There we go. Okay, cool. So when you first, you guys might not have seen this, but when you first connect your wallet, you can register as a builder. So you can just click this little register icon, and that will kind of create you a Speedrun Ethereum account. And then, we've been talking about this all day, but everything you do involves signing a transaction. So what you do is you send a message here and you say, I want to join and register as a builder, and you give your public address and you sign that. So that will actually creates you an account, right? In this open way, anybody can do that, right? And then you have this little punk wallet, which is really awesome. And then you have a portfolio as well. So you can come here, you can add your social media contacts, and you can see all of your existing challenges that you've worked on. So we're gonna start and do a challenge, right? And then we're gonna be focused on this one here, which is the token vendor. Now, once you get through these 3, right, you actually get invited into the build guild. So your profile gets upgraded. So that would be my challenge for the next couple weeks, is try to get to that point as well. Okay. So what are we going to be building today? So let me kind of zoom out a little bit. Actually, maybe that was better. So the cool thing about smart contracts is they're kind of like vending machines in the ethos of Ethereum. So this is really cool because you can interact with the vending machine to do whatever you want. And so what we want to do is create a vending machine that allows anyone to go to and be able to buy tokens. So basically we want to create a token vendor, right? So someone can come, send some ETH into the contract, and then get back some kind of token, right, in exchange. In this case, we're going to be calling it gold. So I love gold. So we're going to be focused on that. And we are going to utilize what's called the ERC20 standard for that. Now, if anyone has ever heard of Open Zeppelin, Open Zeppelin is a security company for the Ethereum, well, for multiple blockchains, but more specifically for Ethereum, they've created these token standards. So we're going to use this ERC20 token standard, which is basically just a token for Ethereum. And we're going to mint some tokens. We're going to be able to edit our front end so that people can come and buy some tokens. And then we're going to publish this and then make it available. So similar to what we did before. So the first section is just going to be setting up Scaffold ETH. So if you are not familiar, we've seen it probably a couple times now that we've gone through and set up Scaffold ETH. In this case, we need to clone the Scaffold ETH challenges repo, right? And in this case, we're going to go into that directory, and then we're going to check out this particular branch. So the challenges repo has all the challenges in it. So you can actually go through and look at all of them, but we're going to be focused on the second one, which is challenge 2. And then we're going to do a yarn install. So now I'm using what's called TMUX, which is a terminal multiplexer. So that's why you see these 4 windows. Actually, I'm going to get rid of 1 window, so you just have 3. So everything you do in Scaffold ETH, you need a few windows open. So I've gone ahead and I've already checked out the repository here. Sorry, I know that's hard to read. But if I do a git branch, we can see that I'm on the challenge 2 token vendor. And I've also went ahead and did the yarn install, but you'll need to go through and do that. I just went ahead and did it to save some time. So after you have that up, so it's always the same kind of commands. First, you're doing yarn chain, which spins up your blockchain, right? Very simple. That's going to spin up all of those play accounts with the ETH and stuff like that for you to play around with. And then I'm going to go to the second window. I'm always going to have that one open, right? And now I'm going to do yarn start. So this is all in the same directory. So I checked out a directory called C2. So we can see that we're in there. And we can see help as well here, git branch. There it is. So now I'm going to do yarn start. So that's going to spin up the front end. So you always do those 2 things, right? And then you keep those running. And the nice thing about TMUX is it just shows you. I would look at TMUX later. You don't have to do that for today, but it's really helpful. And then the last one is that we're going to do that deploy. So we're just going to go ahead and deploy whatever contract is there, just so that it's deployed. And we're just going to make sure that it deploys successfully, which it did. So it tells you that you deployed it successfully. It tells you how much gas it cost, which is really useful, and it tells you the contract address. So now we know that we've kind of gone through this environment setup, right? With all those commands: yarn install, yarn chain, yarn deploy, yarn start. We've got everything working, right? So now we can load up the app. So again, Scaffold ETH runs on localhost 3000, port 3000. It's React with Next.js. So we got everything up and running, and it's working. So we have the debug contracts tab, which is here, and we have, it's a little slow for some reason. I think the internet's kind of acting up a little bit, so it might be a little slow. Let's see. Okay, that was very slow. It's not normally that slow, I swear. But we can see here that we have a contract that's already deployed, and we can see that it has some details, like it has a name, it has decimals, it has the gold GLD symbol, and it has a supply of 0, because we haven't minted any. But let's go ahead and load up the project and take a look at it. Okay. Okay. So, so here we have just the standard Scaffold ETH project. Inside the hard hat folder is where we're going to spend most of our time today. And then inside the contracts folder, we have 2 different contracts. We have a vendor, and then we have a token, right? So the cool thing is you can deploy contracts, and you can inherit contracts and kind of connect them together. So that's kind of what we're going to be doing in a little bit here. But I want to just go through the first kind of steps that it's going to ask us here on the token. So the first thing it's going to say is like, okay, you need to edit your token file, the Solidity file, to basically inherit ERC20 from OpenZeppelin. And then we want to also mint 1,000 of our tokens times 10 to the 18th power to our front end using the constructor. And then we're going to deploy that using the reset command. After we do that, we should be able to see the balance, and we should be able to transfer stuff around if we want to, okay? So how do we do that? Well, it's actually very easy, because we've your token Solidity file that comes with this project actually already has the ERC20 imported right here. Let me go up a little bit bigger. So we already have it here. Now you'll see that this particular package comes with the ERC20 solidity file that lets you create a token. So when you import this token like you do here, you can then inherit the token inside of an existing contract. So you can see here that we have a smart contract that's called your token. And you see this little is right here? So this says that this token is an inherited token from this standard or this existing implementation. So basically we're saying, okay, like create this new token, use the ERC20 that's referenced here, and this will get you access to all the variables, functions, modifiers, basically everything that's inside here is going to be available to you in this contract. So that's really, really powerful because this contract is kind of like certified as being a trusted and, well, Turing complete, I guess, or feature complete contract. So we can see that we already mint, well, we already create the name of the token. So it's called gold. And we have the symbol, which is GLD. But what we need to do is actually mint the tokens. So we actually have it already written here. So we can just uncomment that out. But what this is going to say is like, okay, well, we want to mint these tokens to an address that we specify here. So what we'll do is we'll grab our burner address here. So we have a burner wallet, right? We don't have to worry about MetaMask right now, but we already have that here. Copy address. And we can paste that in here. So what this is going to do, so underscore mint is a function inside of ERC20. So we can call mint, pass in an address, tell it what quantity we want. So we want 1,000 times 10 to the 18th power because we want to get 1,000 of these, but we also want to get them in full like way, right? So we have a larger amount. We can break it up, you know, into smaller increments, okay? So all we need to do is save that, and then we can do a deploy -- reset, okay? So that's gonna take the contract, gonna redeploy it, and you'll notice that we get a new address. So before we had this address here, now we have a new address for the contract, which is here, and we can also see that the gas increased too. So we went from 564 to 614,000 gas. So as we start adding to our contract, the gas increases, okay? But at this point now, we can come to our app, we can grab the address again, and we can check the balance of this address, right? If I check the balance there, cool, it says 1,000. I have 1,000 these tokens. But I also could check Vitalik.eth, and I could see if he has any tokens. Why is that not valid? I think it's because the internet's not working. There it goes, okay. So he doesn't have any tokens, but I have them. I'm more rich than Vitalik. Okay, so you get the idea. We've created, now this total supply has changed from 0 earlier to 1,000. So now I have these 1,000 tokens. So we kind of know that we're moving along, right? We set up the environments, we created a mint. So we minted these tokens. We can balance them. We can also transfer the tokens. So if I want to pull up an incognito window like this and go to localhost 3000, I can get a new burner wallet. And I could transfer some tokens if I wanted to by sending to this one if it loads. I'm not sure, but the internet is just slaughtering this demo a little bit. Oh, 4,000 milliseconds. Okay. Okay, well, that's okay. But we'll see if that loads in a little bit. Otherwise, we'll keep going. Okay. So if I wanted to, I could actually come here and I could transfer some tokens right here. But you can see that when we imported all of the, we imported the ERC20 standard, we get access to all of the functions that are in there, right? Which is really useful. And there's also modifiers as well. But it's really cool because we can start exploring to see what functions are available. So let's keep going. Okay, so now what we want to do is we want to create a vendor, right? So what does a vending machine do? Well, it takes in cash or fiat, or in this case, ETH, and then it gives back something. So we want to give back some tokens. So we need to set basically like a price variable for how much our tokens are going to cost per ETH, right? So that's the first thing we want to do, is say, okay, we want to say that in this case, we will define a variable for the vendor. So this time we're kind of done with the token. The token doesn't really have much function other than just minting the tokens. And we'll probably have to change this in a little bit, but for the most part right now, we're just going to focus on the vendor from here on out. Let me zoom this over a little bit. Okay. So the vendor is very similar, but it's not an ERC20 token. It's just a standard kind of smart contract. But what's important is we're actually inheriting the existing token address from the other contract, and we're also importing it like this using just the Solidity file. And then we just have this like very basic vendor. So what we can do is we can define a variable inside of the contract. So in this case, let me just reference this to make sure. Yeah, so we want to just drop it basically in here. So we're going to say basically, okay, for so this is an unsigned integer. The 256 is like the size, the max size of the integer. So you could actually lower this a lot more if you wanted to. You could do like 128, you could do 64. Just for the sake of thing, you always want to put what it is. You could also just do uint, and it would just give you the max, which is 256. But we're going to just do uint 256 because that's kind of best practice. We're going to make it publicly available. We already talked about that. That means that it can be accessed inside of the contract or externally. It's a constant, so we don't want it to change. And then we just want to call it tokens per ETH, and then we want to define 100, right? Okay, so we can do that. We can save that change. And then what we want to do is import ownable next, which I think it's going to ask us to do that. So at some point, it's going to ask us to do ownable. So inside of smart contracts, every smart contract needs to have some kind of pattern for access control. So if you're going to store ETH inside of a contract, you need to find a way to get it out. Because if you put it in and you don't have a way to withdraw it, it will be lost forever, right? So what's cool is OpenZeppelin, again, has created a set of contracts called the ownable contracts, or the ownable contract, I should say. And it's right here. So we can import that like this, and we can say that your vendor is ownable. And what this is going to do is it's going to give us an access control pattern for our contract so that later on, when we want to withdraw funds from the contract, we can check to make sure that someone is the specific owner. Okay, so let's save that. And let's try to deploy. Let's see if it works successfully. Okay, works successfully. Okay, so what else is it going to ask us to do? So, so we want to create the buy tokens function that's already available in the vendor. It says that it should use the message value and the tokens per ETH to calculate the amount of tokens that you should transfer to the sender, right? And then we also want to, it's going to ask us to emit an event. And then it's going to ask us to update the deploy script so that it deploys properly, okay? So for this, what we're going to do is we are going to, let's see here. So here we want to create a payable function. So in this case, that's the withdraw function. Okay, so we want to do a function. We want to call it buy tokens. And we want to make this function public and payable. So publicly available, payable is so that it can receive funds because we need to actually send some ETH there. So the function is called by tokens. It is public, which means that anyone can interact with it. One of the first things that you'll learn with Solidity is that you can create require statements. You guys probably saw this earlier, but we want to basically require that whoever is interacting with this particular function actually is sending some value, okay? So the first thing we want to do is get the message.value. So we might have talked about this earlier, but there are what are called global variables that are available during a transaction. One of those is the message value, and one of those is like the message sender. So message value is how much actual ETH is being sent in the transaction. Message sender is the public address of who called that. So we're going to say, okay, in order to call this function, you actually need to have sent more than 0 ETH. Otherwise, you need to send some Ether. And then we're going to set the amount. So uint 256 amount equal message.value. That. And we also could, I mean, we could do this a little bit different, but we could also do it like this. We could say uint 256 tokens equal amount. God, I love AI. It's making so much easier. So what we're going to do is we're going to say, like, what was the amount sent in the transaction? And we get that from the message value. And then how many tokens should we actually mint based off of that amount? So the way that we get that is we can say the amount times the tokens per ETH, which is defined here. And then that will give us the amount of tokens. And then we can also do uint 256, get the token balance. So your token dot balance of, and then we want to say address of this. I think that's right. So then this is going to get the current balance of the smart contract. So basically what we're going to do is we're going to load the contract up with all of the tokens that it needs to be a vendor. And we're going to allow people to withdraw from that your token or purchase from that contract. So we need to be able to get the balance. So this is, I'm doing this in a very like explicit way so that you can kind of see these different ways that you can interact. There's probably a more optimized way to do this, but at least you can kind of get an understanding of what that looks like. The next thing is we can do a require statement to basically check to make sure that there's enough tokens in the contract to be purchased, right? So what we can do is say require that the tokens, there we go, require that the token balance is greater than or equal to the amount of tokens that need to be purchased. Otherwise, there's not going to be enough tokens in the contract. And then lastly, we'll figure out who the buyer is. So we say address buyer is message sender. And then now we can do the transfer. So what we want to do is we want to call the transfer function of the existing your token, right? And we want to pass in who the buyer is, and then we want to transfer the actual funds if it was successful, right? So we can do something like this, and we can do the same thing that Tam did, where we can say Boolean success, or let's call it sent, just to say consistent, and then like this. So basically, if the transfer is successful from your token, then create that variable. And then we can do a require statement that says sent, otherwise failed, something like this. Yeah, that should work. Okay, so this, let's walk through it real quick. So we're going to say, all right, require that the person is calling this function has a value of at least 0 in the transaction. Otherwise, they need to send some ETH. Create a variable that's the amount, which is the value. calculate how many tokens that they're going to be able to get after they've sent that. Check to make sure that the balance of the token has enough tokens. If it doesn't, then say there's not enough tokens. And then on top of that, figure out who the buyer is, and then send those tokens by doing a transfer call on that other function, right? And then pass that. And this is only going to work if the Boolean is successful. Otherwise, it would be like failed transfer or something like that. Okay? Okay, so that should work. The last thing I want to do is also talk about the event. So we want to create an event. The cool thing is the event's already written for you here. So we can just uncomment this one. And we can see here it's called buy tokens. So like I think the best practice is to capitalize the events. So in this case, it's buy tokens, capital, which is the same as the function. And what an event does is it just passes some information, omits that information so that your front end can see it, other protocols can see it, block explorers can see it. It's pretty much anything important that you should log or you want to log, you put into an event. So in this case, we want to log who the buyer was, how much ETH they wanted to buy, and then how many tokens, sorry, how much ETH they deposited and how many tokens they got back, right? So we can keep track of that. So I think this should be good. We just need to omit the event. We can do that later because I think it's going to ask later. We could also do just while we're here, we can create a sell tokens event because I know we're going to need it. Address, oh, that's not useful. Seller, UINT 256, amount of ETH. And then UINT 256, amount of AI is not helping me because the internet probably is messed up. Okay, so let's just try to deploy this and we need to actually update the deploy script too. So we've made all these changes, but we actually have, with Scaffold ETH, for every contract you have a separate deploy script, okay? So we have the vendor and we have the token. So the token we don't need to change because it's pretty much good to go here. But the vendor, we need to actually make it deploy the vendor. So as of right now, it's not deploying. So you can see here that it's actually already written for you. So you can just grab all of this stuff and then uncomment that out. So Hard Hat uses TypeScript basically to do a deploy, or JavaScript, depending on which version you're using, how you have it configured. But we want to use all of this code, and it's, like I said, it's already written for you. I think what's most importantly is that we use the deployer account that comes with Hard Hat to deploy the contract. That's kind of a good thing to know. We also pass arguments here to get the token address. And we also do a transfer to transfer some ETH to the vendor address. So we actually need to put our front end address here to also transfer ownership of the contract. So what I want to change is two things. First is I want to mint all the tokens to the message.sender instead of the front end address, because we want to actually send the tokens to the deployer account first, and then we want to physically transfer them to the vendor. So it's kind of like a two-part thing. So the tokens will be minted here to the Hard Hat account, and then they'll be transferred later on to the vendor so that people can buy them. Okay, so let's save that. Oh, save, make sure everything's saved. Okay, this is saved. And now we can put our front end address here. So let's grab that. I hope this is gonna work. Okay, front end address. Boom. Okay. It's kind of weird. Sometimes you need quotes, sometimes you don't. In the case of TypeScript, we're putting that in quotes. If you're using Solidity, you don't use quotes. That's generally. Okay, let's try to deploy it now. Fingers crossed. YOLO. Da, 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 da. Oh, what did I do? Your tokens, buyer tokens, inside. Something with the vendor. Your token, about transfer. Oh, maybe. Oh, do we want to do message.sender actually here? And then get rid of this. Tokens. That should work, yeah. Let me try it again. There it goes. Oh, I didn't like the comma. You're right. Okay, cool. All right, the deployed. Thank gosh. Okay. All right. So now let's go and check out what we have here. So now we have a total supply of 1,000, right? But now if we check the, let's look at the thing here. So we have the ability. So when you try to buy tokens from the vendor, so I already kind of fixed that because I did a transfer here in the contract. We can look at it real quick. But here we transfer the tokens to the contract. And then we also transfer ownership of the contract. So I already fixed some of this stuff. But we should be able to now go to our thing. Let's reload. And we also need to open up, I believe, the front end so that we have access to buy the tokens. Let's see if it's available. I don't think it is. Token vendor. Okay, so we're missing the ability to extract the tokens here. So I think what we need to do is come into Next.js, go to the app, go to the token vendor, and just, I guess, retroactively, I'm going to go through here and like uncomment this stuff so that it's all there. Because basically they have you do this kind of one by one in the thing, but I think what I just want to do is just uncomment this stuff so that we have it available. So in this case, we're going to get rid of this. So these are all comments. So in this case, we want to just kind of get rid of the commented out stuff so that we just have all this available in our front end. Ideally, you like follow the documentation and kind of understand how this works. But I think at this point, okay, cool. So now we have this buy tokens function. So it says that we should be able to buy 100 tokens. If I've written the smart contract correctly, I should be able to buy 100 tokens per ETH. So how many tokens do I want to buy? Let's choose, I don't know, 2 tokens. No, probably more than that, 2,000 tokens. It's going to ask me to buy tokens. It's going to tell me that I don't have enough ETH, right? Oh, there's not enough tokens in the reserve because I only have 1,000. So let's just buy 2. Buy tokens. And now it's going to tell me I don't have enough funds. So I need to get some funds from the faucet. So I can just click that. Now let's click buy tokens. And there we go. So now I was able to buy 2 GLD. And then I could also, now that I have the access to the tokens, I can also transfer them. So I can come over here and I could basically transfer them to this address. So I can grab this address here and I can say transfer to, send 1 over here, send tokens. Now I only have 1 token. Now if I come over to this incognito window and go to token vendor, this one has 1. So I've created this token vendor. I've been able to go in, send some ETH, buy some tokens, and then send them to my friend, right? So we got the buy tokens working. Cool, we're about halfway through. Now we need to do the sell tokens side, okay? So we have the ability to buy tokens. We've deployed the contract. We've minted the tokens, sent them to the vendor. We're pretty much good there. So now I think we want to focus more on the vendor again, and we want to do, we have 2 different things. The most important thing, I think at this point, is to create a function that allows us to withdraw, okay? So the main purpose here is we want to be able to get that ETH out or after the fact. So like I was saying, at some point you want to take some profits on your application. Well, you need a function to withdraw. So we're going to call it withdraw. Oh, if I can spell correctly. So function withdraw, we're going to make it public, but we're going to make it only owner. So cool thing about AI is it wrote it all for me. But what this is going to do is going to say, okay, I want to withdraw all of the ETH that's available inside of the contract. So it's kind of like a rug pull. So I'm going to create this withdraw function. It's only the owner can call it. So if you remember earlier, we inherited ownable and we inherited here. What's cool about ownable is if we click it and look in here, there's a special modifier called only owner. So a modifier is kind of like a function, but you can have it run as a requirement, similar to like a require statement before a transaction is executed correctly. So we do this thing called check owner, which makes sure that the owner is the sender of the actual contract. So it's a way for you to do access control for, like, obviously we're dealing with real funds, so we need to be very safe in that sense. So we have this function that says, okay, anyone can call it, but you can only actually successfully call it if you're the owner. We get the balance by checking the balance of the contract. If the balance is greater than 0 or less than 0, then we can't withdraw. Otherwise, we will transfer the balance to the person or to the actual owner. We could also change this to like message.sender or something like that. But I think for the sake of this, I think this should be good. Actually, let's see if it works. Sure, let's do it. Does yarn deploy reset? Can I save it? Yep. Okay, so now I've kind of reset the contract. Let's buy some tokens. Let's buy 20 tokens. It was successful. Now I have 20 tokens. So there's 20 tokens in the contract. And I'm the current owner. So if I go to debug contracts and I go to, let's see here. Oh, maybe I can't see. Oh, yeah, here. Oh, your token. Actually, the owner is not set. Oh, there it is. Sorry. Okay. So I can see that the owner is 0xA4 right here. So I'm the current owner of the contract. So if I was to come over to this guy, this kind of incognito guy, and I see that there's some balance in the contract, right? I'm like a malicious actor and I want to withdraw that ETH from there. We want to make sure that I can't do that. So we did that. We created the only owner access control pattern. So now if I go to debug contracts, I can see there's some ETH there. So if I wanted to try to withdraw it from this account, it's going to tell me that I'm not the owner. See how it says ownable, caller is not the owner. But if I go to this particular contract and I go to withdraw, then it's successful. So I know that the access control works correctly. So that's really important. Anytime you're dealing with withdrawing funds, you want to have some kind of access control. Okay, so the next thing we want to do is focus on the sell tokens. Okay, so let's try to knock that out. So the last thing is to sell tokens. Okay, so we want a function called sell tokens. Same thing, we want it public. I don't think it needs to be payable, so we can skip that. We want to define a int 256, and we want to get the balance of the contract. So we could do token balance equals your token dot balance of, and then we can pass in the address of this smart contract like that. I think that should work. And then we can require. So we can require that the token balance is greater than or equal to the amount. Oh, that's the other thing, is we want to actually pass in the amount. So let's do that at first. So we want to say, okay, well, if someone wants to sell tokens, they're probably going to say how many tokens they want to sell. So we're going to say uint 256, and we're going to pass in an amount. So in this case, this function is going to take in an unsigned integer. And then we want to make sure that there's enough tokens to actually sell, right? Otherwise, we're going to pass this error. And then we want to calculate how much ETH that we need to basically send. right? So we can say UN 256, in this case, amount is equal to underscore amount divided by tokens per ETH. So in this case, we're doing the opposite. We're not multiplying, we're dividing the amount of tokens per ETH. And we're going to also require that there's enough ETH to pay, right? So we can say require amount, require the address of this smart contract's dot balance is greater than or equal to the amount. Otherwise, we'll say, I don't know, not enough funds. There we go. Okay. So at this point, we're creating a sell function that allows us to make sure there's enough tokens to be sold. Make sure that the balance is there. Make sure that they can get the funds. I think that should be right. And then the next thing is we want to transfer the tokens to the contract. So in this case, we'll do your token dot transfer from, or actually it's just transfer from the message dot sender. Oh no, it's transfer from actually. Transfer from message dot sender, the address of the smart contract, and then the amount that's being passed, right? So in this case, we're going to do that. If it doesn't work, so if the Boolean doesn't exist, we can say failed transfer. And then I think the last thing is we need to like omit. Oh, we need to transfer the ETH. So in this case, we're doing the transfer from on the tokens, right? So this is doing the sender, the amount of tokens. And then we also need to pass in here. So let's do Boolean. We'll call it sent to, I don't know, yeah, sure. Equal payable message.sender. And then we'll do a .send, I guess, amount. And then we can do a require statement as well that requires sent to, otherwise failed to send ETH. Okay, and then the last thing is we created an event already. It's here, it's called sell token. So we can omit that event. So we can do omit sell tokens, pass in the message.sender, pass in the amount, and pass in the amount of ETH that's being passed back as well. Okay, I think that should be good. Are we omitting the event here as well? Oh, we're not. We should do that too. So buy tokens, so we should omit the buy tokens event. So in this case, it's buy tokens. This is amount tokens. Let's make sure that's right. Okay, that should be good. All right, let's save that and let's try to deploy. One. What did I do here? Address of this dot balance. Oh. That doesn't need to be there. Okay, sure. Oh, did I do the sent to sell tokens. Sell tokens. Did I name it right? Sell tokens. Oh, here. Okay. Some small typos, but I think I got them worked out. Whew. All right. All right, it worked. Okay, so now I should be able to go back into the app. So I've created the ability to buy tokens. We've showed that. Now let's go to the token vendor and let's refresh and let's get some funds from the deposit just to make sure we have enough. So in this case, let's buy 50 tokens, right? Now I can buy those 50 tokens. Let's say that I want to transfer those to my buddy over here. So I can come over here, copy the address, and we're just kind of testing as we're going. Let's send him 25 of those tokens. So now he has 25. So now he should be able to come in here to the vendor, and then he should be able to sell those tokens. Now, when you're working with ERC20, you need to basically approve a transfer before you can actually do the transfer. So you can see here that we have this approve button, which allows us to call the approve function. So in this case, let's say that I want to just sell like 10 of my tokens. I can approve that I only want to sell 10. Approve. Oh, I need some gas. Okay, let's try that. That's weird. It's a UI bug. All right, 10, approve. There we go. So I approved the sale of 10. Now I can sell 10. Sell tokens not found on ABI. Oh, maybe I didn't name something correctly. Let's see. Oh, I didn't do the function name correctly. So let's save that. Let's redeploy. So this is kind of how you do it. You start tinkering and toying around. Okay, so now I should be able to do that again. I'll just do it. This time I'll just do it from this account. So let's buy 50 tokens. It worked. Let's approve the sale of 10. Approve. And then now let's sell those. There we go. Now it's successful. So now I have 40 tokens. So I bought 50 tokens. I approved the transfer of 10. And then I sold 10. And I still have 40, right? And now the contract has half of an ETH. So now I could pull that stuff out by coming to debug contracts and do a withdraw. And then I get all that back into my wallet. So now everything's working. The way we can check is to do the test. So let's do that. Yarn test. So this is going to run hard hat test. And it's going to make sure that it passed. And it did. Okay. We're success. So it passed all the buy, sell, withdraw, the approve function, the transfer function, and the vendor and the your token are all working correctly. The block limit's set. It's enabled optimizer. We're good. We're good. Okay. So the next thing we want to do is deploy it. We just went through this again, but let's do it again. We're going to do, so we need a deployer account. Like we want to put this on a test net, right? Let's just make sure I did everything first. Let's go here. We came in here. We did ownable. We did the vendor buyback. Everything's working. Now we want to deploy the contract. In this case, what we're going to do is we're going to deploy it to Sepolia. We'll use Sepolia again. So what we can do is yarn account. Sorry, that's not correct. Yarn run generate. So yarn run generate is going to generate us a private key and a public key, and it's going to store the private key inside of our directory in the environment variable file here. But we have a public address. So we could do yarn account, and I could pull out my Punk wallet, and I could fund it. So let's send some Sepolia ETH. See if I can do that. Actually, you know what? I'm just going to do it the easy way. I'm just going to grab the address here, and I'm going to send some from this wallet here. So I have, oh, I already have some here. So I have 1 ETH. So I'll send that. I'll send it to that address, and I will send 0.2 ETH next. So I'm taking some funds that I have in my MetaMask, sending them to that deployer key. So now that should work. So now if I do yarn accounts, it's going to go through and check my balances, right? There we go. All right. Sepolia is working. Okay. So I was able to send some funds to that deployer. So now I can do yarn deploy -- network Sepolia, right? So what that's going to do is take my contract, compile it, see if it needs to compile, which it didn't. Then it's going to ship it to Sepolia by doing a create, basically. And it's very slow, but that's okay. We'll give it a second. And it's going to deploy that. The next thing we need to do is get our front end ready. So while that's doing that, let me open up, be able to get chain ID. Okay. While that's doing that, I'm going to go into the C2 directory here, and I'm going to do a yarn, was it Vercel YOLO dash prod? Is that what it is? Oh, wait till the contract's done. Oh, yeah. Thank you. Okay, so, oh, it's deploying both the contracts. I hope it has enough gas. So if it doesn't, it's going to tell me, but I think it's good. 0.2 ETH, we're good. Okay, cool. So that was successful. So now our contract has been shipped to Sepolia. So we can update our front end. So we go back down in here. We can go into what's called the scaffold config. You probably saw this earlier. Let's chain the chains to Sepolia, like that. We could also update some stuff here. Lower this. What is this? This could be false. That's a good one. Okay. So now we can load up the front end and make sure that it's showing the proper contract. Okay, so there it goes. It's deployed to Sepolia. We can click it and see. Okay, while that's doing that, I'm going to do a yarn Vercel YOLO dash prod or dash prod. No, let me just get it here. Oh, great. Oh, here it is. Yarn Vercel dash prod. Okay. Okay. Yes. Boom. Yes. Okay, it's uploading. Okay, so let's see if the contract worked. Okay, so it was deployed successfully a minute ago. One thing you'll notice is that on the contract tab, we have the bytecode here, right? We talked about bytecode today. It's unreadable. So you should also verify your contract. I don't know if Tam did that, but I'm going to do that real quick. So how we do that is we just do yarn verify -- network Sepolia, because we need to, well, we need the contract verified. Yeah, so Tam would have had to have done it in order to get the results back from BillGittle or from Speedrun Ethereum. So now it's verifying my contract. So when you verify the contract, it's basically comparing what you deployed to what your source code is to make sure that they match, so that people have an open view of what your contract does. Because you don't, you want to operate in an open way. This is an open source conference. So that's why we verify our contracts. And there we go. So it's working, verified. So now if we come here and refresh, we'll get the verified contract. You can see all the code that I wrote here. Here's the ownable contract. And here is the ERC20 and the token and the ABI. So everything's good. The last thing we need to do is just make sure that that ships appropriately, which it should be good. But in the meantime, let's grab this and let's try to let's see if it passes our test. So we can go submit challenge. So we can do here. And then this might take a second. While that's doing that, it looks to me like we have like 10 minutes. Oh, here we go. Okay, so production. I don't know if it's going to work yet, but we'll try it. Let's see. Submit. It's going to ask me to sign my transaction. Sign. Cool. Deployed, submitted. And at some point it should verify it, but we did it. We deployed the app. So I have like 5 or 10 minutes for questions. So I guess at this point, I'll open it up to you guys and see if you guys have any questions about that. Got to be at least one question. At least one question. Come on. Otherwise, we'll take a little bit of a break and then we'll do the data indexing. Did you?
Yeah.
Did I miss something?
No, not at all. You did a great job. You were talking about how smart contracts have different role-based systems. But I would also add to that the best smart contract doesn't have an owner, right? The best kind of smart contract is like algorithmic and doesn't have any way for anyone to be able to pull any money out. And it works in a different way where they pull the money out based on the rules of the system and not if they're the owner or not.
Yeah, that's a good way. That's a good point. Yeah, I think we try to build things in the ecosystem that are like game theory, interesting, cool apps. And so, yeah, that's the power of smart contracts is you can just kind of let go and let them do their thing. And you can build some really cool stuff with that.
Telegram channels. As you're doing these, there's a Telegram channel.
That's a great point. So for every challenge that you go through, there's a specific Telegram channel that you can get support for. And I think it's just down here at the bottom. Yeah, here it is right here. No, it's somewhere here. Problems, questions. Here we go. So we have this. So we have the Scaffold ETH main developer chat. So if we click that, that will take you there. There's also, I think there's a link on the top. Yeah, Austin? Oh, here it is. There's a special Telegram chat for every single challenge. So you can go into this, you just click it. It's going to load up your Telegram, and then it's going to invite you to the group. I won't open it, but yeah, so do that if you get stuck. If you just have general questions about Scaffold ETH, you can just go on to the main Telegram chat. I'm not sure if anyone talked about it, but the Scaffold ETH IO, there's a docs that's really, really good. We didn't really get into that too much, but I think in here, like anything you want to know about Scaffold ETH, all of the components that are available. So there's an address component, balance component, inputs, any of the ways you interact. So the hooks are all here as well. So if you want to read from your contract, it gives you an example. If you want to write to your contract, if you want to subscribe to events, this is how you would do it. If you want to see all the history of events, if you want to just get contract info, whatever, there's all documented really well. So yeah, the docs are great. If you have any questions, we'll be around for a little bit. And yeah, any other questions?
Cool. Okay. Thank you so much, Kevin. That was amazing.